Thanks to everybody who took the 2021 Magic Math Mock AMC 8 contest. It was a little harder than the normal AMC 8, and that's because we wanted to prepare you guys more for it. Before the solution starts, don't forget to check out our website at magicmath2000.com and subscribe to our YouTube channel, because then you'll get notified when we post new videos and new contests. But anyways, here's the solutions. Problem 1. So, in this problem, we have a triangle ABC, and it says that angle A is equal to angle C. So this is isosceles triangle. So let's draw a triangle A, B, and C. And since we know A and C are equal, let's just mark their angle as X. Well, in the problem it also says angle B is 45 degrees less than A and C. So it's X minus 45. And then we know that in a triangle, the angles sum up to 180 degrees. So the sum of these angles would be x plus x minus 45, or 3x minus 45 is equal to 180. Bring the 45 to the other side, divide by 3, and we have x is equal to 75. But remember, it's trying to ask us, what is the measure of angle B? And that's x minus 45. So the actual answer would be 75 minus 45, or 30, which is answer choice A. Problem 2. So we have a triangle with area of 6, and then perimeter of 12, and then all of the side lengths of the triangle are tripled. So if all the side lengths are tripled, and the perimeter is just the sum of the side lengths, the perimeter will also triple. So it will turn into 36. And one important fact to know about all shapes is that if you increase the side lengths by some factor, so let's say by 4, the area will increase by a factor of 4 squared, or 16. So in this case, we're increasing all of the side lengths by 3, so all the area will increase by a factor of 9. So it'll turn into 6 times 9, or 54. And then if we add these together, we get 90. So our final answer is D. Problem 3. So this is a probability problem. We have container A and container B with 6 red balls and 4 blue balls, and container B has 7 red balls, or 7 blue balls, and 3 red balls. And we have to find a probability that if we choose one ball from each container, they're the same color. So both of the balls can be either red or they can both be blue. So let's take these case by case. If they're both red, the probability of picking red from container A is 6 by 10, and the probability of picking red from container B is 3 by 10, because the number of red divided by the total number of balls in the container. And this is 18 divided by 100. And same thing for blue. 4 by 10, because there's 4 blue balls, and 7 by 10, which is 28 by 100. And now let's add these fractions together, and we get 46 divided by 100. And don't forget to simplify, so this turns into 23 divided by 50, which is answer choice D. Problem 4. So in this figure, we need to find the area and perimeter and then add them together. So first, let's find the perimeter. So we know this other side length will be 5. This side length is 3, so then this side length will also be 3. And since this whole side length is 17, and this side length is 7, and this side length is 6, 17 minus 7 minus 6 is 4, so that will be 4. And now let's add them all together. 17 plus 5 plus 7 plus 3 plus 4 plus 3 plus 6 plus 5. And if we add all of these numbers up, we get a number of 50. So 50 is the perimeter. Now let's find the area. So this figure is like a rectangle, and then we take a rectangle out of it. So first let's find this area of the big rectangle, and then minus the area of the small rectangle. So the big rectangle is 5 by 17, so 85 is the area. And the small rectangle is 3 by 4, so minus 12. And this is equal to 73. So now let's add the area and perimeter, and we get our answer of 123, or answer choice A. Problem 5. So one trick you can do in money problems is just ignore the decimal and add it on later, because that just makes the numbers a little easier to see. So 450 cents, but then Jeff and Joe only have dimes and quarters to pay with. So we can make an equation, since we know they have 24 coins in total, and the dimes plus quarters is 450 cents. So let's say the number of dimes is D, and the number of quarters is Q. So D plus Q is equal to the total number of coins, or 24. And then 25Q, because that's the value of a quarter, plus 10D, because that's the value of a dime, is equal to the total value, or 450 cents. And I'll solve these equations using the process of elimination. So first, let's multiply this equation by 10. We get D, or 10D, plus 10Q is equal to 240. And then minus this equation from this equation. So we get 15Q is equal to 210. Now let's divide by 15, and we get Q is equal to 14. But remember, we have to find the number of dimes there are. So let's plug in Q back into one of the equations. So D plus Q is equal to 24. So you can see that D is equal to 10, and our answer choice is C. Problem 6. So we have Annie, which we can say is A, Bob, B, Clyde, C, D, Devin, and E, Eva. And they start by saying 1, 2, 3, 4, 5, and then they loop back. So it goes A, B, C, D, E, 6, 7, 8, 9, 10. So one thing we can do in these looping problems is take the remainder by how much they're looping by. So in this case, there's 5 people. So if we take the remainder when all of these numbers are divided by 5, we get 1, 2, 3, 4, 5, and then again 1, 2, 3, 4, 5, and repeating. So we see A connects with 1, B connects with 2, C connects with 3, D connects with 4, E connects to 5. So if a number has remainder 1 when divided by 5, Annie says it. If it has a remainder of 2 when divided by 5, Bob says it, and so on. So let's look at the number 2021 now. When we divide by 5, it has a remainder of 1, because 2021 is 1 greater than 2020, which is divided by 5. So we know that since it has a remainder of 1 when divided by 5, Annie says it. So our answer will be A. Problem 7. So a very useful trick, which may seem like cheating kind of, is in the AMC 8, notice that they give multiple choice answers. So there's only 5 possibilities for what the answer could be. So in algebra problems like this one with absolute values, it's going to be hard to do the algebra by itself. So why not just guess and check all of the answer choices and see which one matches? This may seem like a little bit of cheating, but it's just how the contest goes. There's multiple choice, so you can bash out some of the problems. So let's start with answer choice A and work our way up. So -1. -1 plus 3 is 2, so no absolute value needed. And -1 minus 15 is -16. So absolute value of -16 is 16. So this does not work. -1 does not work. So now let's try 1. 1 plus 3 is 4. 1 minus 15 is -14, which turns into 14. So 1 does not work either. Now let's see 5. 5 plus 3 is 8, which is equal to 5 minus 15, -10. So 5 does not work either. Now let's try 6. 6 plus 3 is 9. And this is equal to 6 minus 15, -9, or 9. So 6 works, and is our answer. And if you want to double check that's the only answer, then you can try 18. So 18 plus 3, 21, is equal to 18 minus 15, 3. So 18 does not work, and 6 is our answer. So answer choice D. Problem 8. So this is a Venn diagram problem. So let's draw our Venn diagram of this school. So let's say this circle's basketball, and this circle's soccer. So we know 566 total people play basketball, which means they're in this circle, and 523 people play soccer, which means they're in this circle. But then we also know that if X is the amount of people who don't play any sport, then 2X is the amount of people who play basketball and soccer. So now, since we know basketball has 566 total people, the people who only play basketball will be 566 minus this region. Because if you see, the total region of basketball is here, and we want to see how many people are in this region over here. So that'd be 566 minus 2x. And same for soccer, 523 minus 2x. And now we know that the sum of x plus whatever's inside these circles is 1,000, because that's the total number of students. So now let's add these all up. We get 566 plus 523, 1,089, minus 2x plus 2x minus 2x, which is minus 2x. and then plus x, which is how many people don't play basketball or soccer. And this is equal to 1089 minus x. And we know this is equal to 1000, so we can see x is equal to 89. But remember, we're trying to find out how many people play basketball and soccer, which is 2x. So we have to do 89 times 2, which is 178, or answer choice C. Problem 9. So we're trying to make a pie chart of these numbers over here. And we want to find out how many degrees are in chocolate. So let's find out the ratio of the number of chocolate, the number of people who like chocolate as their favorite dessert, to the people interviewed. And then we can multiply that by 360 to find out how many degrees there are. So 67 people like chocolate. And then if you add these up, there's 180 total participants. So 67 over 180 people like chocolate. So now let's multiply this fraction by 360 degrees. And we see that this is double of 180. And we get 67 times 2, or 134. So our answer is B. Problem 10. So here we're going to use something called complementary counting. So we're trying to find out how many arrangements don't have the math books put together. But that's kind of hard to do. So let's find out the total number. And then minus the number of arrangements that have the math books placed together. So the total number will just be the 5 distinct books arranged in any order. So that'd be 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is 120. And now let's find out if the math books are together. So we can imagine, if you put the math books together, them as a really huge book. And then we have the 4 other books, or 3 other books. So now how many ways are there to arrange this giant book and these 3 other books? Well, that's 4 factorial, since there are 4 distinct objects to arrange. So 24. So you might be thinking 120 minus 24, 96. Boom, done, easy. But there's a catch. It says the math books are also distinct. So if they're A and B, then they can also be arranged BA in the giant book. So now we have to multiply 24 times 2. So actually, we have to do 120 minus 48, which is 72. So our answer is C. Problem 11. So you can imagine picking 2 points on this 8x8 grid of dots. So let's say the first point is this one. Well, we want to find out what's the probability that the second point creates a line. So it would not count if the second point's here, because they don't create a vertical line. It's diagonal. So let's say we pick any first point. Well, the way we can make a line with a second point is if it's on the column of that point or the row of that point. So for any point we pick, if that second point is in that row or column of that, then they'll make a vertical or horizontal line. And the key importance that you notice is any point you pick, there are always 14 points that you can pick on the row and column. Because if you draw a line, so 1, 2, 3, 4, 5, 6, 7, plus the row 1, 2, 3, 4, 5, 6, 7. So there's always 14. So it doesn't matter what your first point is. It can be any point. It's just that the second point has to be 14 out of the 63 remaining dots, which if you simplify is 2 divided by 9. So that gives us our answer of A. Problem 12. So in this problem, we're going to use a concept called harmonic mean. So it says that Albert goes 40 miles per hour to the city, some X miles per hour back, which is what we're trying to find, and then the average speed is 48 miles per hour. So what harmonic mean says is that if you have 2 speeds, A and B, and the important thing is that A and B have to go the same distance. So in this example, Albert goes 40 miles per hour to the city, and then X miles per hour back. So he goes the same distance. So then it says that if you drive A miles per hour, let's say, and then B miles per hour back, the harmonic mean would be 2AB divided by A plus B. So we have A, we're trying to find b, and we have this average. So now let's just plug in the equation. So we have 2ab divided by a plus b. So a is 40, b is x. So 2 times 40 times x divided by 40 plus x is equal to the average, or 48 miles per hour. Now let's solve. 80x and multiply both sides by 40 plus x is equal to 1920 plus 48x. Minus 48x from both sides, 32x is equal to 1920. And divide by 32, x is equal to 60. So you get our answer of 60 miles per hour, or D. Problem 13. So we want to find out how many cubes in this 4x4x4 cube are painted on 0 sides. So the number that are painted on one side is these middle cubes for all of the faces. And the cubes that are painted on two sides are these edge cubes. And then the cubes that are painted on 3 sides is the 8 vertices. So the cubes that are painted on 0 sides is actually the inside of the cube. So that would be a 2 by 2 by 2 cube that we can't see in this picture, but you can imagine is kind of contained inside this 4x4x4 cube. So since it's a 2 by 2 by 2 cube, the number of cubes inside this is 8. So we get our answer of C. Problem 14. So we have a 5-digit number, and it starts with 1 and 3. And since we're supposed to maximize it, let's try putting as many 9s as possible. So let's fill the first 2 digits with 9s, and then see what the last digit has to be for this number to be divisible by 9. So for it to be divisible by 9, the sum of the digits has to be divisible by 9. So the sum of the digits so far is 22, which is 1 plus 3 plus 18. So we see the closest multiple of 9 is 27. So if we put a 5 in the last place, then it'll be divisible by 9. And just to double check, this is the maximum possible value. If we add 9 to this, it's 14004. So that's too big, it doesn't start with 1 and 3. So our final answer is D, or 13,995. Problem 15. So the best strategy in these problems is to find out what's the worst case scenario, or what's the maximum number of socks you need to pick to guarantee 10 pairs. So the worst case scenario would be if, let's say, we pick one sock out of all 25 pairs. So we pick the 25 socks, because that's like, you don't get any pairs from the first 25 socks you pull. So now, every sock you pull will guarantee a pair, since all 25 pairs, you've already picked one sock out of them. So if you pick 10 socks, it'll give you 10 pairs. So the maximum number of socks you need to pull is 35. So our answer is D. Problem 16. So we have a cube, and we're trying to find the total number of face diagonals, space diagonals, and edges. So let's start off with the easiest one, edges. We know there's 12 edges in a cube. And now let's go to face diagonals. So there's 6 faces, and then each face has 2 face diagonals that are in an X like this. Basically, it's going diagonally across the face, which is why it's called a diagonal. So there's 6 faces and 2 diagonals per face, so there's 12 face diagonals. And then for space diagonals, it goes diagonally across the whole cube. So you have to take 2 completely opposite points, like here and here. So now let's count how many space diagonals there are. So with one, which I just said, then a second one like this, a third one like this, and then a fourth one like this. So there's 4 space diagonals. So if you add these all up, you get 28 total lines, or answer choice E. Problem 17. So the first thing you should do when you see these long sequences of numbers is to find out if there's a pattern in them. And in this case, the pattern is, it's 1 less than all powers of 2. So it starts off 2 minus 1, which is 1, plus 2 squared minus 1, or 4 minus 1, 3, plus 2 cubed minus 1, all the way to 2 to the power of 10, or 1024 minus 1. So let's first add up all of these powers of 2, and then we can see how many 1s we have to subtract. So this is 2 plus 4 plus 8 plus 16, all the way till 1024. And a fact about adding powers of 2 is that if it's like 1 plus 2 plus 4 plus 8, all the way till some 2 to the power of n. This is equal to 2 to the power of n plus 1 minus 1. So in this case, 1024 is 2 to the power of 10. So this would be 2 to the power of 11 minus 1. But notice, there's no 1 here. So we have to subtract 1 from both sides. So minus 1, minus 1. So this would be 2 to the power of 11, or 2048, minus 2, or 2046. Now let's count how many negative 1s there are. So 1, 2, 3, and so on. So it starts off from 2 to the power of 1 minus 1, then 2 squared minus 1, then 2 cubed minus 1, all the way to 2 to the power of 10 minus 1. So if you count how many of these numbers there are, there's 1, 2 to the power of 1, then 2, 3, all the way till 10. So there's 10 of these groups, or numbers, so there's 10 negative 1s. So if you do 2046 minus 10, which gives us 2036, or A. Problem 18. So the pattern here is that we have to find a number that's remainder 1 when divided by 2, so it's 1 less than a number divisible by 2, and then remainder 2 when divided by 3 is 1 less than a number divisible by 3, and so on. So this number is going to be 1 less than a number divisible by 2, 3, 4, 5, all the way to 10. So if we just find the LCM of 2, 3, 4, 5, all the way till 10, and then subtract 1 from that, that will be our least number. So let's do that. So the easiest way to find the LCM for numbers is to find the prime factorization first. So let's find these prime factorizations. 2, 3, 2 squared, 5, 2 times 3, 7, 2 cubed, 3 squared, and 2 times 5. And then what you do next is for each of these prime numbers, so 2, 3, 5, 7, you find the greatest exponent in all of these numbers. So greatest exponent for 2 would be 3. Greatest exponent for 3 would be 2. Greatest exponent for 5 would just be 1. And same for 7. And if you multiply this out, you get 2,520. But remember, we have to do 1 less than this. So it would be 2,519. And that gives us our answer choice C. Problem 19. Here we're going to again go through all of these people and guess and check whether they can be first and if they satisfy all of the conditions. So let's start off with Aaron. There's 4 spots. And let's say Aaron is first. Well then, Aaron's statement that he is first in line is correct. But then Devin's statement that Aaron is first in line is also correct. However, only one of these statements has to be correct. So, Aaron cannot be first in line. So, no Aaron. Now let's try Devin. So, Aaron says he is first in line, that's wrong. Devin says Aaron is first in line, that's also wrong. Jeff says he is first in line, that's also not true. And Katie says Jeff or Devin is first in line. That is true, since Devin is first in line. So the answer must be B or Devin. And let's just double check if the other ones don't work. So Jeff, Aaron says he is first in line, wrong. Devin says Aaron's first in line, wrong. Jeff says he is first in line, true. Katie says Jeff or Devin's first in line, also true. So Jeff, 2 people are true, so that's wrong. And then Katie, let's see. If Katie's first in line, then Aaron is not first in line, Aaron is not first in line, Jeff is not first in line, and Jeff or Devin are first in line. So now 0 people are correct, and this can't work either. And it can be determined, because we just found out that the answer choice is B or Devin. Problem 20. So this expression might look very scary, but we're going to use the binomial theorem here. Why? Because if you know the binomial theorem, this might look very familiar to the expression x plus 2 whole cubed, which is x to the power of 3 plus 6x squared plus 12x plus 8. If we could somehow add 8 to this expression, we get x plus 2 whole cubed. So let's do that. We can add 8 to this whole inequality. So we get 24 is greater than or equal to x plus 2 whole cubed. So we can factor that now. Is greater than or equal to negative 26. Notice how you add 8 to these 2 numbers also. And it also says distinct integers. So since x is an integer, this whole cubed must be a perfect cube. So we know it's a perfect cube somewhere in the middle of 24 and negative 26. And the only perfect cubes that satisfy that is 8, 1, 0, negative 1, 8, and that's it. So, it looks like there's 5 integers, but let's just double check quickly. So 8, x is equal to 0, because 0 plus 2 whole cubed is 2 cubed, or 8. Then negative 1, negative 2, negative 3, and negative 4. So they're all distinct integers. So our answer is D, or 5. Problem 21. So again, we're going to look for a pattern since this is a really long sequence. So the pattern is 1 divided by 1 times 2 plus 1 divided by 2 times 3 plus 1 divided by 3 times 4 all the way till 1 divided by 49 times 50. So how does this help us? Well, this is a very common telescoping pattern. And what do I mean by telescoping? Well, it was coined that name because if you expand the telescope, you can also push it in and collapse all of the segments into one segment. So let's see how that works. We have 50 or 49 segments right now. But a unique thing about this number is that if you do 1 times n plus 1, this is actually equal to 1 by n minus 1 by n plus 1. So just to show that, 1 by 3 times 4, this is 1 by 3 minus 1 by 4. Or if you use equivalent fractions, 4 by 12 minus 3 by 12, or 1 by 12, which is 1 by 3 times 4. So now let's use this property. So if we go back to our main expression, let's lower this a little bit. We can do 1 minus 1 by half plus 1 by half minus 1 by third plus 1 by third minus 1 by fourth all the way till 1 by 49 minus 1 by 50. So now, negative half and plus half cancel out. Negative 1 third cancel out. Negative 1 fourth cancel out. And everything cancels out till negative 1 by 49 minus 1 by 49. So we're left with 1 minus 1 by 50 or 49 by 50. So this turns into A. This just shows how important finding patterns and telescoping is to really long numbers. Problem 22. So if you've taken my Magic Math contests, which we did this summer and last summer, you're probably very familiar with this problem. And if not, this is a sticks and stones problem. And here's just a quick recap of what sticks and stones is. If we have some amount of identical objects, so let's say we have 5 identical objects, and we want to give them to some amount of different containers, or different kids. We're trying to split them apart into some amount of things. So the key part here is that those containers or kids have to be distinct. So let's say in this example, we're trying to give it to 3 kids. Well, we can say that those 3 kids are 2 sticks, because then it splits these objects apart into 3 separate containers or sections. So now we can just assign these to the kids. So let's use that fact here. But 4 of the kids want at least 1 toy, and the 5th kids want 2 toys. So let's just give those kids what they want before we do sticks and stones. So 20 minus 4 kids want 1 toy, so 4 toys, and then the 5th kid wants 2 toys. So that's 6 toys in total. So this is 14 toys we have left, and we want to give them to 5 kids. So this is equivalent to 14 toys, or 14 stones, and 4 bars, because there's 5 kids. So now we just have to find out how many ways there are to arrange 14 toys and 4 sticks. And if you not choose, this is 18, because there's 18 total objects. Choose 4, because there's 4 sticks. And if you calculate this out, this is 18 factorial by 4 factorial times 14 factorial is equal to 18 times 17 times 16 times 15 by 24, or 3060, which gives us our answer of D. And if you want to see more sticks and stones problems and more examples of sticks and stones, watch my previous contests from this summer. They're in my YouTube channel and they're labeled from 1 through 5. Problem 23. So the important fact to note about this problem is that Team A and Team B don't have anything different other than their name. So we can find the probability that Team A wins over Team B by just finding the probability that any team wins and then dividing that by 2, because the probability that Team A wins over Team B is the same as the probability that Team B wins over Team A. However, the thing that makes this problem difficult, and the reason the answer isn't just 1/2, is that draws do not count as wins. So now we have to subtract the probability that there's a draw first and then divide that by 2. So the probability would look something like 1 minus the probability of a draw, and this divide by 2. So let's find the probability that a draw happens. So that can happen by both teams getting either 0 goals, 1 goal, or 2 goals. So let's first do 0 goals. So there's a 1/3 chance of not making a goal. So Team A would have a 1/3 times 1/3 chance of making 0 goals, and Team B would have a same 1/3 times 1/3. And it's equal to 1 by 81. And now for 1 goal, Team A has a 2 times 2/3 times 1/3, because 2/3 times 1/3 is a probability of making 1 goal, because making a goal is 2/3 chance and not making is 1/3. And the reason there's a 2 here is because they can make the goal on the first shot or the second shot. So 2 times 2/3 times 1/3, and then same for Team B, 2 times 2/3 times 1/3. And this is equal to 16 by 81. And then for them making both goals, this is 2/3 times 2/3 times 2/3 by 2/3. Which is equal to 16 by 81 also. And if you add these all up, you get 33 by 81. And now simplifying this, you get 11 by 27, and then 1 minus this is 16 by 27. And then finally we have to divide this by 2, which is equal to 8 by 27. So our answer is 8 by 27, or answer choice A. Problem 24. So this problem looks very complicated, and the hardest part about this problem is knowing where to start. But notice that there's an angle of 45 and 60. And where have we seen those angles before? Well, in a right triangle. So if we just drop our perpendicular from C to AB, we see that this is a 45 triangle, a 30, 60, 90 triangle. So let's just draw here to get a clean slate. So this is our triangle, and then we drop our perpendicular, and we know that this is 45, this is 60, this is 45, this is 30, and this is a right angle. And then we also know this is 6. And now we want to find AB. So first, we know that A to this middle point over here will be 6 divided by root 2, or 3 root 2, and same thing over here. And now, this is opposite the 60-degree angle, so opposite to 30-degree angle, it'll be 3 root 2 divided by root 3, which is root 6. And now we have the sum 3 root 2 plus root 6. And it's asking for the answer in the form root A times B plus root B. So we can write this as root 2 times root 3 plus 3. And we get B is equal to 3, A is equal to 2, so A plus B will be equal to 5. So A is our answer. Problem 25. So we know we have a 4-digit number, so it has to be between 1,000 and 10,000. And we want it to be divisible by 4, 3, 5, and 7. So first, let's find what numbers are divisible by 4, 3, 5, and 7. Well, it's going to be numbers that are multiples of the least common multiple. So let's find the least common multiple of 4, 3, 5, and 7. Since they all have no common factors, we can just multiply them. So this is 20 times 21, or 420. So we know it has to be a 4-digit number that's a multiple of 420. So it can be 3 times 420 all the way till 23 times 420. Because this is the maximum multiple of 420, less than 10,000, and this is the least multiple of 420, greater than 1,000. However, we're not done yet, because it's not divisible by 11. So it can't be any multiple of 11 times 420. Specifically, it can't be 11 times 420 or 22 times 420. So 3 to 23, that is 21 numbers, and we have to subtract 2 numbers. So that's 19 numbers. So the final answer is C, or 19. And we are done with the solutions.